Okay then, that's probably about it. Good afternoon, my name's David Walker and I work for Worldpay. Who are Worldpay? Worldpay are a payments processing company. We do around 40 million transactions a day. That's about 472 per second. On a peak day, we do somewhere at the order of magnitude of 12 to 1400 a second. Which is the busiest day? Christmas Day? Black Friday? No. None of those days. It's 11th of November. Why 11th of November? Well, in China, they have China Singles Day, where you buy presents for your single friends. And this is a bit of a hallmark type event, because 5 years ago it didn't exist. And the first year after they came up with it, it moved for about $5 billion US dollars through the system. Last year, they did $20 billion through the system in one day. It's quite a few transactions. We've got 400,000 merchants. We're using 300 payment methods. So things that you'll see in that are Bitcoin, credit card transactions. In Kenya, you'll see mobile-to-mobile payments. So we gear up to deal with all of those payments types. 126 currencies, including Bitcoin again. 142 countries. And in the UK, we process 42% of all the non-cash transactions. That means that if you've been to the UK, you use your credit card 3 times, we've got your details. Hey, look, when I see this, I'll tell you about some of the records we've loaded, but when I see a table with 65 billion transactions in it, 64 billion of them belong to my wife, and the rest of them belong to other people. So, these are the companies we provide for. So when you're doing this, we are behind Apple Pay. If you've used Apple Pay in the UK, it's gone through the iPhone, it's gone to Apple, and then it's gone through Worldpay. If you're buying a movie on Netflix, if you're going to Tesco's shopping chain, if you book it anywhere in the world on Airbnb, Skype, AliExpress, which is where we get to the China things, and all those big companies. But we also do 16,000 hairdressers, 24,000 restaurants, and of course the important 9,000 bars. And after today, when you go and pay somewhere, especially in the UK and parts of America, if you see, you'll see a little thing which says Worldpay, and you go, oh yeah, actually, I'd never noticed that before. In April 2015, which is the second anniversary on the 1st of April, we had cake in the office last week, we had a very strange event for me. That man sitting there introduced me to the then CFO of one of the Worldpay divisions. And they said, yeah, we're thinking of doing something called the Enterprise Data Platform. I'd like you to come along and run it. And I said, okay, this is Friday afternoon. Nice to do it. Yeah, I'll come in Monday and I'll discuss it. Monday morning, I turned up. And I was introduced to the CIO as, here is the new program director for the Enterprise Data Platform. There was one of me. It's been a long journey. There's now 50 of us in my team. There's another 50 doing building and analytics. We've hired 50 people in that time to build a cluster. What else is the thing? We're driving towards deep analytics, source information across all our platforms, making it available for our colleagues, exploit disruptive open source technologies, and a huge commitment. Because of the way that Worldpay came into being, we have no legacy Teradata's or Netezza's or anything else. We separated from RBS in 2008, and so we have no legacy architecture. This is it. The only other reporting system in the business at the time when I joined was a 5 terabyte month-on-month reporting system. So suddenly to put in what's now 100 nodes in the cluster, 5 petabytes of data, 2,500 CPUs, all the rest of it, over that time, build it out, secure it, has been a huge undertaking. It's got to be secure. One of the interesting things and one of the big challenges about this is if you're going to drive that level of things, it has to be really secure. There's one table, the card table. The card table has the card number. It has the start date, the end date, the name, the CCV. And I've got it here. It fits if you export it and compress it onto a memory stick. Now, We don't do that, surprisingly. We don't do that because that would be very, very valuable and there. So all the data is encrypted. It's a very secure cluster. It's got Kerberos, it's got data at rest, tokenization, encryption, data in motion, encryption, physical security. But that's a challenge because the system that we want to build is about having open access. So we describe it as a secure, operational, multi-tenant system. Secure for obvious reasons. Operational, by the time we finish rolling it out, we want anybody in the business who needs access to have it. We've got about 200 users actively using it now, or 200 registered users on it, but we're going to get it out to all 6,000 employees. But over the next 2-3 years, we're also going to push it out into the cloud, and we're going to have our business partners using it. And we're going to have people like fraud partners using it. Some stats. Well, 96 nodes. Security is key. In that time, we have done every release and every patch release. So 2.3, 2.3.1, 2.3.2, 2.4, 2.4.1, 2.4.2, 2.5, 5.1, 5.2, 5.3, and as of last night, I instructed the team to start work on the 2.6 upgrade by the end of next week. Why? Well, first of all, there's security patches. We're fussy about this. But also, we're doing this because we want the new features of things like Atlas. We want to fix the problems that we've had with Spark so that we can roll it out to things. We have to build a rapidly evolving environment. We've now loaded over 80 billion card transactions. And in that replication, we've added from doing batch replication in the last 4 weeks, we've turned on real-time streaming from one of the transaction systems. In the first week of doing that, we took through 1.9 billion card transactions. Real-time streaming into Kafka and Flume and going on to reporting. And we're just going to sweep through. We've now got a rollout plan over the next couple of months, which is going to drive out how we do all of the operational systems. And we're process delivering users and systems. And when I say delivering to users and systems, one of the things I'm going to talk about is something called decision services, where a system is going to interact quite dynamically with us. So what's a multi-tenancy cluster? I've been to some of the other talks, talked to a number of people. People talking about multi-tenancy tend to say we've got 5 or 6 projects running on 20 projects or whatever. We're starting to think of it like this. Think of the Shard. It's a nice building in London. It's the only one I could find a red picture of, and we've got to do corporate colours. So a building like this has got offices, it's got retail arcade, it's got restaurants, bars, hotels, possibly accommodation. And each of these different types of usage needs different services in the building. So we've got water, gas, electricity, air conditioning, internet security, building management to build those sorts of things in. But the needs of each of these different tenants or different tenancy types is quite different. So when we start mapping that through, we have tenancy types. We have multiple data warehouses. We have multiple decision services, multiple data APIs, tech insights, search. And these tenancy types need to different types of information being brought into them. They need batch, they need streaming data. They need the data lake or derived data set, ingest, reporting, engines for running models, governance, security. So we start to think about how do you build this cluster up and what we're doing. So the first tenancy is one that you'd all recognize. It's the data warehouse offload exercise. What we've done there is taken 2 systems, one called Shopper Insight. Shopper Insight takes all the data, card transactions, and looks for profiles for merchants. So we will help a merchant understand who their customer is. That's got one narrative model, about 7, 8 tables in a star schema, relatively small, but it does have all the transactions in it. We've got another data warehouse. We're not trying to build them as a big single enterprise data model. The second one that we've got is for our new acquiring platform. It's called Consolidated Acquiring Reports. And it's designed to bring together all the information off our different platforms and tell us what the financial situation and liabilities are with it. And that's several hundred tables, sourced from about 10,000 tables in source systems. The next one we have is decision services, and this is the one I'll drill into a lot. But with decision services, the idea is to make it operational. The idea is to put a service into the transaction path. Now, you all go shopping. You all stick your credit cards in there. You don't want to be stuck at the till. Milliseconds, tens of milliseconds. We actually get about 100 milliseconds in the transaction to interact with that. What sort of things do we want to do? Well, we might want to check whether somebody's entered the PIN right, whether they've passed the CCV. For an organization which is doing web e-commerce stuff, one of the challenges is whether you put the dynamic 3DS. That's the screen that pops up and says verified by Visa or MasterCard accept or whatever it is. I should learn the MasterCard one because somebody will be sitting in the audience one day from them. But it pops up. Now, if it's the first time you've gone to a shop online, you've just spent £1,000 on a bed, actually it's popping it up is quite useful. If it's the third time you've shopped there, and this time you're picking up £20 worth of pillows, the customer doesn't want to have this popped up. And actually, on a second visit to a shop, a large number of customers drop off if it comes up a second time. We actually see the drop-off rate. So we change the outcome for how things behave by putting in decisions into the service. Data APIs. You've seen all these customers that we've got, the big corporates. We are now looking at how to build out a set of regular APIs so that our portal strategy, our customer interaction can come and share the data with us. That's incoming data to us. So Google might give us search patterns, for example, and we may see transactions from another merchant, or we can blend a footprint in stores with online advertising, because we know from their mailing list who are their loyalty cards. We work with a retailer to look where their ads were placed in Google and who's actually shopped over those pieces of time. But doing that needs really secure large data sets, and this is one of our targets for burst to the cloud with it. So what we will do, especially as Hortonworks 3.0 comes along, is actually look to export this to stand-up clusters to work with partners. So we keep it secure in-house. We develop all of these components. Tech insights. The scary thing on a day when you are doing 1,200 transactions per second is that the systems go down. That's kind of bad news. It's also when you get a denial of service attack on a web. It's also when you have a potential crash. So what you want to do is start looking at the router behavior and start looking at the number of fraud cases coming in and whether people from a particular country are doing particular scams. So there is a market, there's a black market right now where one country in the world is getting sent large numbers of stolen credit cards. And what they do is they try them. They donate £1 to a charity in the country of origin of the card. Most people look at their credit card and see, oh, £1 to that charity, probably did that, probably did it mobile or something, don't care. Charity gets the money, they're not complaining. And the scammers know that that card is active. And the value of that card on the black market goes from $3 to $15. So this becomes actually really quite interesting to see what's happening, where these attacks are coming. Also, if a router's about to fail on a busy day. So we want to join up everything from the router at the bottom to the transactions going through the system and see the patterns and understand those ones. And that's going to be a big data science project that we're going to be doing. Search. All this data coming in. The next largest part of our new acquiring platform is to develop something around the ideas of an operational event store. So all of our systems are being modified to generate events. So a change of address happens in one system, how does it get replicated? We want to have a store of all of those events that are being generated in the organization. And with that store, what we want to be able to do is search on it quickly. So a customer comes to you because of GDPR requirements and says, tell me about how you moved our data through the systems. Search is more than just finding the data. It's being able to account for the fact that it came from A and went to B. So why tenancy types and not just tenancies? Because operationally, once you get to scale, building this out is difficult. If you let 50 projects all do their own thing, and then you have to upgrade rapidly, or you have to change something, or you have a version of software, you have to be able to identify and manage that migration through various versions. So what we do is we pin down a tenancy type. Your data warehousing tenancy type 1, that means you use our in-house type tool Pelt, you do batch, you get Tableau as a front end. You're our tenancy type version, data warehousing version 2, you get Kafka streaming, you get at-scale reporting, you get Flume ingest. But we can then group all of these things and plan our migration for components across the system. If we don't do that, what's going to happen, and I'm seeing this with other people that we're talking about, is a rush into delivering projects as multi-tenancy. We've got 5 projects live on our cluster. And then a sudden grinding halt when you get to the point where you've actually got to manage those upgrades across all of those things, because it's not going to be individual models. It truly is very specific and different use cases about what you're trying to do. We can manage SLAs. So actually, another important part of operations is to be able to say the core cluster can be shut down. Why would we want to do that? Well, occasionally we want to do maintenance. But if we've got a component in the cluster that has to be up 7x24 like the decision service, we have to be able to, by isolating it and having a well-defined type, we can actually say this component can be shut down or suspended or use cache, or what we have is a concept of fail open, so that we can manage the service level agreement with business for taking those components down. So we are able to manage the interaction with how we build these components out. And then we can also start to do compliance stuff in terms of what we have, what data, how we're moving data, and where it is, because that, with GDPR, becomes much more important. And I want to talk a little bit about how this changes and why we've started investing quite heavily in getting to this place. Hortonworks 3 is coming along, and at the moment we use components. We just say Tableau sitting there and being able to do it. But we have to start thinking about how we upgrade, how we migrate to Hortonworks 3, and how we take advantage of containers. So I need to deploy a group of containers which will satisfy a tenancy type. And I need to identify those and build templates and architect for that solution. And the roadmap to Hortonworks 3 is 9 months. It's end of Q1 next year. So we have to think now how we're going to start isolating that containerization onto our system and how we plan the migration. We're not going to do a big bang on that migration either. What we're going to do is bring the cluster up, move it over without containerization, and then bring the tenancy types into that one. But we'll say, right, we're going to do all of the decision services into containers. We're going to do all of the data warehouses into containers, bring those on and move them across. And that then allows us to have multi-versions, so we'll be able to run multi-containers as Spark versions or of Hive or whatever else it has to be. But it allows us to do it. And underpinning this is the real concept for us of an on-premise data lake. We have data as a resource at the bottom of this, and we can build service groups sitting on top of this, which allow us to operate the system for different people at different levels of service and availability. So the trouble is, if you don't start thinking about it now, where do you get to the point where you've got to do the upgrade, and how difficult is that upgrade going to be? So this is why we've started to really try and pin down and hone our tenancy types to drive that component. We operate in gold, silver, bronze. Good architecture means the ability to isolate these for maintenance. But you have to strive in a big architecture to keep things at the lowest level of things. We want to keep everything bronze if we can, because it affects our cost base. How many operators do you have to have available overnight? Who's going to be on call? If you've got everything at gold and it's a 7x24 service, you need a big team to support it. If you can drive that down to a small team and small components, the advantage that you have is being able to put just a few people on call. Furthermore, if you can distribute that out, so our operational systems, because they get the decision services, can have a box close to them doing the decision service, they will support it out of hours, and we don't have to get out of bed at all, which is obviously my personal preference. And we use this. We have a Hortonworks first policy for the Hadoop platform. What that means is in order to keep that support and that matrix going, if it's available in Hortonworks, we use it. So we won't necessarily run off and get the latest version of Spark because it's not yet been deployed into Hortonworks. But we use that Hortonworks first policy to define what we're going to get. Operationally, this is about having one person to go and shout at when I need to. We don't have to shout at them often, but when we do need to, we want to have somebody, we don't want to say, oh, you installed that yourself. We've got this whizzy tool that we got from somewhere else. We've got this, got that. How do we integrate it? We want to be able to go to them and say, this is the problem we're having. Let's deal with it. So we are architecting multi-tenancy to be a solution long-term. I started at the beginning talking about when I joined and the size of the team. 70% of our team is permanent. So over that time, we have consultants on site from two vendors. We have some contractors. At any given time, we have long-term contractors. But actually what they're being done is churned off projects and then coming back onto other projects and permanent people being done. So we're building this thing for a vision of it existing for 10 years. There's no short-term in this. So building and architecting a solution which drives towards that sort of long-term vision of having data as a platform is really important to us. And to put it in perspective of how important it is to Worldpay, our core operational platform is called an acquiring platform. That does the transactions. We have gateways, which move the card data through between us and banks, customer-facing digital services and infrastructure. And the vision is that when we have finished all of this lot, we will have one acquiring platform, one gateway solution, one enterprise data platform, the infrastructure, and one set of portals. So Worldpay is going through a massive churn in their organization to replace all 15 acquiring platforms, bring them into one place. We don't have any legacy reporting, which is quite nice. I don't have to deal with it. But bringing all of that through and then making it a sustainable option which will last for the next 10, 15 years. So I want to talk through what one of these tenancy types might look like. So the decision services one is quite an interesting one, as I've alluded to. And we set up this by saying the ability to ingest data in real time from operational systems. We're using a Unity, Kafka, and Flume, and a data capture job to do that. The ability to analyze data either on the stream as it arrives in Kafka or historically in a Hive database. The tools to allow the data scientists to machine learn, Spark using Python and Scala ML libraries. The ability to publish and run machine learning models to offer a service. For that, we're publishing the machine learning model in PMML and pushing it out to open scoring. And from that, the open scoring server is actually sitting with the transactional system. The ability to allow other systems to access the decision service via a RESTful API. So in order to change all of our existing operational systems easily, we've settled on a RESTful API. It's versioned. It's got authentication, so we can actually use it internally and sell it to business partners. And it is it's independent, so that it can be taken down. So we can do A/B testing, we can do upgrades on it, we can also load balance it and all the other things. So there's quite a lot of design just in getting that node done. The Hadoop cluster does the core work at the center, but it doesn't have to be up to run with this thing. And then the ability to support decision services in production, which is all the work that nobody likes to do at the end of the project. Hey, we've got whizzy machine learning, great. But actually what we want to do is disaster recovery, integration testing, performance tuning, all those sorts of things. And that defines the scope of the tenancy. We sat down, a set of words, a set of tools and technologies. And now we are building out on those ones. So we've started on 3. Here's the actual mechanism of one. Down at the bottom, here is the things coming in, scoring data, the data lake, and the core modeling. Our data science team now have this set of tools. Goes into our workflow management and version control. Up into the model management, which is PMML with GitHub. These are the ones we're working on. These are actually the decision services published out. RESTful API out to the operational system, which uses Kafka to bring the success or not of the interaction back into the cluster so we can feed it back in a virtuous loop, and then ultimately out to the customer. And this is what we're trying to do. This is our outcome, our business outcome size. So none of this involves people. We don't need reports to do any of this. This is actually about integrating it. We want a customer to be able to choose. Choice is what we're trying to deliver to the customer. And for us, choice to the customer means how much do you want, how much do you want to pay for it? The cost that you pay your acquiring vendor depends on how much risk the acquirer is taking. If you're prepared to take any old card and if it defaults, you take a risk, we don't take any risk. If you want to say, if there's fraud on that card, I want my money anyway, we charge you a little bit more because we're taking the risk. Acceptance rates. How many of your cards go through first time? Now, you'd think all cards go through, but actually with networks and things, they have things you can do to balance acceptance. So actually, you may want to take a bit more acceptance because it's good, but for higher cost or lower cost or risk. And we want to be able to change our risk profile. So we want to manage those three things. As a customer doing acquiring, we've found a combination to the point that we actually want to give this on our customer portal to premium customers as a premium service, the ability to tune these components. And then we can look at what answers. Do you need more security? Do you need more card history, card type, region, customs, all these things? These impact what they do. And as a result of a combination of the data that we have, plus what you ask for, we decide what to do. We won't bother doing fraud processing. We will send it to the CV2 validator. Don't do AVS. Don't do dynamic 3DS. Do a retry if it fails the first time. And route it via system ABC. I had to take out the actual name of the system in there because that's restricted. But the ability to tune this into an operation. We've begun to look at what this does. This is a graph, something called interactive account verifier. It's to do with $0 auth. When you go into a shop, sometimes they'll validate your identity by putting the credit card in, and they either charge you a nominal amount, $1, or they charge you $0. We looked at, keep pressing the wrong button, looked at the impact on the top 10 customers that use this sort of service that we provide now. This is where we were declining customers. Actually, if we varied this thing with machine learning, all of that amount was recoverable. So in other words, instead of declining them, we have the ability to change the outcome so they wouldn't have been declined. And the graphs here are quite stunning. We have the existing current solution that we have does that. More is better. The more under the line is a larger turnover. The green line shows you the hybrid model where we're doing supplementing it late in the processing payment. And this model is what we get if we put it in early. So if we put it if we put the decision early on in the processing, we can significantly uptick what we come. That's one decision service, and I've had to anonymize some of those data, and that particular outcome was for one merchant who uses this type of input a lot. So it's quite an extreme example. But it does demonstrate what building a tenant like is, and the ability to deploy multiple of these ones, it becomes very important. We also have a technical insights one, which I was talking about. So we're now looking at our estate. Our Oracle servers, physical access logs, that's people coming in and out of the building at odd hours. I recently had a workshop in the office. I brought some cider up from where I live in the southwest of England. I rocked up at the office at 2 o'clock in the morning because I'd driven up late, dumped the stuff out of my car because I could park outside the office. And the next morning, security asked me what I was doing in the office at 2 o'clock in the morning. Telling them I was bringing in a stash of booze because it's difficult in work was probably hard. But you can look at potential physical risk. You can look at potential levers. You can look at people getting in there who shouldn't be getting in there at that time of night, people who've got tailgating friends. We're paranoid at Worldpay about security, so we actively have people who will try and tailgate us into the office. Organised by security, from a security company, try and follow us in, who got into the building, when, what data can they see. We want to look at web servers, our firewalls, our antivirus, SNMP traps, Linux servers, and bring that through to an event capture area, event store, and then an analytics workbench. From there, yes, reports, yes, dashboards, search, investigations. But the real key goes back to the same machine learning that we've been doing. That's going to give us advanced analytics, machine learning. And then we're also going to integrate with third-party security products. All of that into two areas. Same data going to two different tenancies. One's going to our security teams, because they want to know about who's getting in at the wrong times, and the other team going to our operational and our IT teams. And this is the sort of thing we are now producing live. This is live Tableau reports of Hive tables, and this is coming and showing trends of a vulnerability. And interestingly enough, all the little grey bits that are there, and there tell you what the vulnerability is. Because I had to carefully mask them out, so I couldn't tell you that we hadn't put patch 1, 2, 3, 4 onto the system. This shows the trends over the month, trending line of what's happening, and we've started to discover things. Some of them are common sense, but as we start to discover things, we're starting to see patterns like this. Everybody measures security from when a vulnerability becomes known to when it's patched. But actually, the first place you want to look is, when did it become known? When did the vendor issue a fix for it? There's no point in having a 90-day patch cycle if vendors don't release patches to software for 60 days. It changes the profile to it. So what you want to look at is the 4 stages. When was the vulnerability announced? How long after was it fixed? How long after was it made available to you inside the organization? Because if you're running an operations team, you don't just download the latest patches off the internet every day. Somebody in your security team will download them there. But are they taking a month to get those vulnerabilities down? And then ultimately, are the teams responsible for the servers taking a long time to do it? So you have various factors which you can impact on it. Certain times of year, we want to correlate things like spam emails with new viruses against patch cycle. So when do you see at Christmas? Do you see a large number of spam emails coming in because they're phishing attempts going into Christmas, and from that they're going after a particular type of vulnerability? In the ideal world, and we're not there by a long way, we're just starting out on this journey, but in an ideal world, we'd like to see what we think the attackers have, by looking at the types of viruses coming in, where are they likely to attack on our system? And we do get denial of service attacks onto our core network every day. But we're also going to eat our own dog food. So this is our internal tool, framework for doing batch. These are the jobs down here, listed down here. Everything has to be grayed out. These are the times of day and how long they're running for. This is the high volume, frequently run jobs. So now that we're running all of this reporting off it, what we're doing is getting the developers to target fixing those ones first. These are the jobs that run frequently and take a long time to run. These are jobs that run frequently but don't take very long to run, so on and so forth. So if you're going to spend time, if you're going to invest it, how do you iteratively improve what you're doing? So we want to learn and do machine learning on right down to that level and interact that with, what's the cluster available? So there's a new one that we're hoping to get very soon underneath this chart, which will actually show us the load on the cluster compared to when the jobs were running. And what we want to look for is any correlation between how many jobs we've got running and the capacity on the cluster. Are things going slowly? Could we reorganize our schedule to do it? So that's our technical insights, tenancy type, multiple types of those things. So where we are now, it's been a 2-year journey. I started with the fact that it's second anniversary. We've got 2 live tenants for data warehousing, both providing reports. We use something we call internally a narrative model. So they're not full data warehousing, they are third normal form, but they tell a story. This is what a card transaction does, this is what a financial report does. So it's 15, 20 tables, third normal form, then built up into data marts. We've got decision services. We've made the code changes. We're now going through the real code, hardened code testing for these operational systems. They will go in over the next months. They will go into all of our live testing. We're doing testing on what the outcome would be at the moment. And we have to take really a lot of care with doing that before we put it, because we're going to affect people's bank balances and transactions. But over the next 3 months, we will deploy those first 3. We think we'll have about 50 that we've identified as an initial tranche, which goes back to multi-tenancy and the subject of this talk. If you're going to do that, if you're going to have 50 tenants which need these sorts of profiles, How do you maintain it? You can compare the cluster to a big VM server. Suddenly we've got hundreds of containers doing hundreds of different things. And if we want to scale rapidly, we have to be able to take this sort of thing in. Data API 1 live now, 15 dashboards, but that's boring. We really want to get to machine learning on that. And we don't even know what our other tenancy types are yet. But they'll come. I'm absolutely convinced that they're just sitting around the corner for us. And these are the people we're working with. One of the things that we've done a lot to do is to have a very low number of vendors. We don't have a large number of people. So whipping around it, networks and some of the hardware from Cisco, other hardware from HP and also HP Voltage, Full Metric for encryption, Think Big, who've helped us with the architecture, the design, and consultancy services, Wishfit for consultancy, Open Scoring for running the PMM models, Tunity for replication, Tableau on the front end, obviously Hortonworks, but at the core of it all is a Worldpay team delivering it. And with 5 minutes to go, any questions? She's just held up the sign. How good timing is that? Sorry, any questions? Yeah.
In this multi-tenant environment, how do you manage the data governance and especially the business definition of the data?
So up until now, we've had to do a lot manually. We started on the Atlas journey. We broke Atlas. We complained to Hortonworks. I did say we'd like to have somebody to blame. We started on the Atlas journey again. We broke Atlas again. And now we're starting on it again. So we've done, there's somebody in the team called Laura. Is Laura in here? She said she might come. No, she's not. She's had the sense not to come. She's been working really hard. So we are now, we've got a lot of logging done with manual steps as we do it at the moment. Lots of it's manual. What we're now driving to do is, it's actually an API call in our framework that does the logging. So we're pushing all of that lot. As soon as we upgrade to, there's a problem with the API between 0.7 and 0.8. So what we're doing is we're focusing on 0.8. We're going to push all of that into the API to drive it through into Atlas. We're also, on a related subject, because we have a data lake with one-to-one copies of all our systems, work that Laura's been doing is going to define our GDPR model inside that. So we can actually use this to identify all of our source systems, what they're doing. So we are already, because we're very much into regulation, we're already talking with the regulators in the UK about how we will map and how we will present a GDPR model, and we're going to use Atlas to do that. Like all of this stuff, this is an arms race all the time. I am forever more busy than I want to be. All of these journeys start. We're moving them as fast as we can. We're not perfect in any single space. I wouldn't want anybody to take away the impression that we're perfect at what we're doing. We run hard really fast. I often describe it to the team as you're running hard, fall over, stand up, run again. Because actually that's all you can do to build this sort of space. You come across hurdles in all software. You live with it for a period of time, then you fix it, and then you move on to the next thing. Yeah, almost. Everybody talks about the panacea of the Spotify model. Read the book about how they got to the Spotify model. They spent 5 years figuring out how to fall over multiple times. Yeah, that's all we're doing. We just run at it hard, figure out whether it's broken, and then fix it. Any other questions? Yes?
The open scoring, is that anything from your Hadoop environment? Or is that
So the machine learning that we've written is written in Python ML, and it writes PMML, which is like an XML format. And then we commit that in, we've got to do a whole bunch of compliance. We commit that into Git, and then from there we publish it from Git into the blue model. So we have 3 nodes running the current model, 1 running the new model. If it lives up to expectation, then we publish it to 2 more and it becomes green, keeping 1 old one. And then after you've run it for a while, you then publish it into all 4 of them. And the reason there's 4 is there's 2 in each data center, and to do green-blue testing, we have to have a minimum quorum of 4. So we can load balance in each data center between 2 of them there. And each decision service has its own VM doing this thing. And those VMs will move to an OpenShift container stack as well as we go forward with this. But like everything else, we're at the embryonic stage of building out our container strategy. So that's something else to do when we get 5 minutes in the evening, because that's where most of the work seems to happen. Any more questions? Yes?
When you're designing your architecture for the data platform, do you pick up someone's experience or some best practices?
Yeah, mine.
You design it from scratch?
I worked in the Dutch police doing a 1,000-node cluster before I worked there, so I had some background in what we were going to do. So I've done both secure clusters and large clusters in a couple of previous jobs. So that's where I got into doing this one. But the team has grown. So there's a guy over there called Christian who helped us with this from Think Big. We brought in domain experts around a number of areas. We brought in security experts. We brought in some Think Big people. We brought in Hortonworks people at different times. We have what we call set-piece workshops, where we get the vendors we think are likely to be interested, plus our own team. And there's a model for them. So in the morning, we talk through all the business problems. In the afternoon, vendors pitch, not product, but how they would approach the solution without naming their product, which is quite interesting. You should watch all the vendors sitting in the same room, trying not to say, our product is the best thing. It's really good fun for us. I have to say the vendors don't like it. But we use that to frame the architecture design, and from that, we then move it on into what we want to do. So we may, having had that discussion, we'll choose the direction we want to go in from. So we try to make it collaborative. It goes back to having a small team. I know just about the CEOs of all of these companies. Some of the couple of bigger ones I don't, but I know the sort of EMEA director and things. We have a good relationship with these people because it's important. Any more questions? I'm being told it's time up, so thank you very much.